and we're about to find out. So, much like yesterday, we're going to jump straight into graphing some polynomials. Having a look at this one, what is your prediction about this one?
Cubic.
What kind of gives away that it's a cubic?
There's going to be 3 x's.
There's going to be 3 x's. So, to start off with, what I'd like to do with this one, I'm just going to rewrite that equation with some expanded brackets. I want a standy-uppy desk. So x minus 4, x plus 2, x plus 2. So while we're getting used to doing polynomials, anytime we've got some powers amongst brackets, I would encourage you to write them out. And the reason for writing it out then, you're not going to make a simple mistake when it comes to multiplying out your terms. For argument's sake, remember when we talked about the y-intercept, just multiply the last things? A lot of people might, and it's a common mistake, minus 4 times 2. Minus 8 would be its y-intercept. But it's not minus 8, because this 2 needs to have, that 2 in that second bracket needs to have the squared applied to it first. So it's really minus 4 times 4. Whereas when we write them out in expanded form, we're not going to make that mistake as often. All right? So it's just a way of eliminating a simple mistake. The other part that I like to see, it makes it really clear. These guys, this x plus 2, that's going to be a repeated answer, isn't it? All right? It's a repeated 0, a repeated root. So it's y-intercept. We'll go through that. What would its y-intercept be? Negative 16, cause of so we've got negative 4, 2, 2, so it's going to be negative 16. Slight delay today, yay, and I've done that in the complete wrong spot, haven't I?
Yeah,
So y-intercept, oh, there we go. Y-intercept, done. Its degree, well, it's going to be degree 3, isn't it? Why is it important to recognise its degree 3? Because that tells us the shape. We've got a Travolta curve, don't we? Yep. Now we've got to figure out if it's this one or that one. So what's its leading coefficient?
1.
Positive 1, isn't it? It's positive 1. Because its leading coefficient is positive 1, we would name that as a monic, remember? Remember when we did factorising? Monic means positive 1 is the leading coefficient. Anything that's non-monic has something that's not 1. So negative 1, non-monic. 18, non-monic, if it's the leading coefficient. So we've got a monic here. And because it's monic, because it's positive, we have the, we know what its endpoint's going to look like. It's doing that one, not that one. All right, you guys are loving the dancing, aren't you? All right, so it's x-intercepts we're going to have. Do you agree x equals 4? Because that first bracket needs to be 4, and those next 2 brackets is going to be negative 2, isn't it? X equals negative 2, x equals negative 2, and the negative 2 is important because that is going to be a bounce. All right? It's going to bounce because there are even number of, so it's even number of same, that's not really good English, intercept. I'm running out of room. No, Chris is right. So because I've got the even number of the same intercept, I'm going to have a bounce. So it's going to bounce off the x-axis at negative 2. It's not going to pass through it, it's going to bounce. Which one is it going to pass through? Just go straight through it. It's going to go straight through at 4. Are we going to wiggle anywhere wiggle through any axis here? We're not going to wiggle because there's not an odd number of repeated intercepts. All right, so we're bouncing. All right, so let's get this graphed. So because we know it's the normal Travolta curve, it's going to start down here and it's going to end up there, isn't it? Oh, you could have told me I needed to scroll my screen up. I'm doing it from my iPad. I'm like, oh yeah, everyone can see everything. I forgot that I'm screen recording that. So it's going to start in the 3rd quadrant and finish in the 1st quadrant. Is that okay? So that's where it's going to start and end because it's got the Travolta. We know, again, at negative 2, we're going to bounce at negative 2. and we're going to cross through at 4. I'll just do it over here somewhere. And then we're down here somewhere at -8. 16, thank you. Now, I did say yesterday that I would normally do this at the very end. But I'm doing it at the start to show you, to kind of get an idea of, I need to bounce off an axis here, I need to come down, and then I need to get back up. Does that make sense? So, okay, so we know we're bouncing, passing, passing. So to draw this, I'm starting down the bottom, I'm going up to -2, I'm bouncing off the axis, I'm coming down to -16, I've got to pass -16, and at some point now I need to turn around and go back up through 4, don't I? So at some point turn around and go up through 4. And this would be y equals x minus 4, x plus 2 squared. And the final part, giving it a name. Is that okay? Remembering, this curve that's down the bottom on the up the right-hand side of -16, this turning point that's down here, do I need to label it now? No. In Year 12, I do. One thing we don't quite know is sometimes this, we can think about it, this turning point, it's got to probably, this turning point here, it could actually be on the left-hand side of the axis. We don't know. It could bounce, come down and turn and then come back up this way. We don't know yet. Okay? In Year 12, when we do the skills, we will know where this point is, so we can draw a better picture. Right now for Year 11, what we're looking for is a bounce. You pass through -16, and somewhere underneath the axis, we know we've got to turn around to get back up through 4. Is that okay? Seem all right? All right. I was thinking back through some stuff last night about how I've taught this previously, and I'm just remembering I'm moving my iPad and not the screen. And I remember a saying that a teacher at my old school said about graphing. And he described graphing as CRP. So we all know the singer Sia. So I'm going to do this one, and I'm going to think about CRP as we do it. All right, CRP. CRP stands for shape. What do you think is going to give me my shape? What's going to give me my idea about my shape? The degree. So when we're talking about shape, that's why we're finding the degree of the polynomial. I is for intercepts. I is for intercepts. All right, so intercepts. I spelled that wrong. I've got to rubber out. So I is for intercepts, which we can see we've got to find out x and y intercepts. A, it's not axis of symmetry. Okay, A stands for asymptotes. How do I spell asymptotes? Asymptotes. All right, we don't have any asymptotes in polynomials at the moment. Remember, asymptotes are parts of graphs that don't exist. We're going to come to graphs that look at that in a second. Hyperbolus, great example. It's got something that's got an asymptote. Okay? And last one, P is point for scale. Right, it's just a point for scale. So, because some curves, for argument's sake, and we'll see in an exponential curve, every single exponential curve kind of looks identical to each other. You just go, done. But if we mark a point on there, it kind of gives us an idea of, at that point, the curve's doing this, so it kind of gives you a rough idea of, oh, this is where that curve actually is. All right? Let's think about the C of P as we're doing this one here. So we're doing x squared outside of x minus 1, x plus 3. You can't actually see that on the screen, but I do actually have an axis drawn there. All right. X squared outside of x minus 1, x plus 3. So we're going to think about CAP, we're going to think about shape. Shape is going to lead us to think about our degree. Have a think, what do you think the degree of this is? It's degree 4, isn't it? Because we're going to have x squared times x times x. So if we multiply all those x's together, that's going to give us x to the power 4. So we've got a degree 4. If it's a degree 4, what kind of shape is that going to have? It's going to have that quadratic shape. It's going to either be praise the Lord or bow down and worship. Cool, let's figure it out. What's the leading coefficient? No, the leading coefficient, it's 1. So is it monic or non-monic? This will be monic. So because it's positive 1, we are praising the Lord. We've got both arms up. The graph is going to start and finish in quadrant 1 and 2. It's going to be, at the end of it, it's going to be both arms up. We okay with that? I haven't confused anyone yet. Cool. X-intercepts, they are going to be what? Big pardon? That's cool. 1 and negative 3. Anything else? Negative 3. How many zeros? There's 2 zeros. Why is there 2 zeros? It's x squared. That's x times x. So we're going to have 0 and 0. What does 2 zeros tell you? We're having a bounce. We're bouncing at 0.
So I don't understand really the bouncing concept. Like when there's X-intercept and there's 2 of them, does it mean it doesn't go through it twice, or it just goes through it once? But
It just sits on the axis. It doesn't pass through it. It sits on the axis. That's what I mean by bounce off the axis. It gets the axis, touches it, and then bounce off it. It doesn't actually go through it. It kind of goes wing and goes in the other direction. Hence, bounce.
okay, I get it now.
Cool, cool? That's what we mean by bounce. Our y-intercept. Our y-intercept is going to be 0. Because remember, there's this x squared out the front. So when I do minus 1 times 3, that's negative 3. But then I need to remember I'm multiplying by x. If I was to expand this all out, there's no random constant floating at the end. What else would give away that our y-intercept was going to be 0? One of our x-intercepts is 0. If our x-intercept is 0, our y-intercept is going to be 0. Cool. I'm going to do that in blue. Cool. All right, so we know because it's positive, we're praising the Lord. We're going to start and finish up. It's going to cross, we know it's going to go through minus 3, which is going to be over here somewhere. There we go. We know it's going to cross through minus 3, which is down here somewhere. We know it's going to bounce off at 0, which is going to be there. And it's going to come back up through 1. What color? Let's do this in pink. So it's going to look something like, I'm going to start up, come down through minus 3. I've got to turn somewhere. I've got to bounce off 0. I've got to come back down. I've got to turn somewhere. And I've got to get back up through 1. Is that okay? It's a praise the Lord shape because it's positive 1. Both arms need to be up. So I started up in the left-hand side. I had to pass through minus 3. So I dragged that line down through minus 3. But I know the next time I get to the x-axis is at 0. So I have to turn around and get back up to 0. But I'm not passing through 0. I'm bouncing at 0. So as I hit 0, I bounce off it and start going the other direction. But again, I know at some stage, once I go that other direction, I have to get back up to pass through 1 because I need to finish up the top.
How do you know which one's to bounce off?
How do you know which one's to bounce off? We're bouncing off 0 because 0 was the repeated intercept. When you have an even number of repeated intercepts, so there's 2 zeros, because it's x squared, that would be, if I expanded it, it's x into x, so both of those could be 0. When it's repeated, I bounce. When it's an odd, I wiggle. If it's a single, I just pass through it. Is that okay? And I'm just going to draw my axis in black because up on the screen it didn't come up. On one note, I do have my axis drawn on there, but it didn't come up in grey on the screen. Is everyone okay with that so far? And remember, Finally, you know how it says point for scale? Now the last part of C, we didn't have any asymptotes because this graph, its domain was all real x, isn't it? So we don't have any asymptotes. Its range was all real y, so I don't have any horizontal asymptotes, which is cool. The last point says point for scale. Because because it has no asymptotes, it exists everywhere. Because it has x and y intercepts, they're points on the graph, aren't they? That's the point 0, -3, that's the point 0, 0, that's the point 1, 1. We have points for scale. We don't need to do anything else. Is that okay? And remembering in year 12, what's the last thing you're going to have to do to this graph when you're in year 12? Label the turning points.
Is that hard?
No. And when you label the turning points, there's another point for scale, isn't there? That will come in year 12. What I would like to do is scroll down. Remember how yesterday we talked about that random polynomial at the start that I got really distracted talking about? Yeah. That one. And then underneath we put
What do you do when the leading coefficient isn't 1?
the exact same process. More when it comes, so the question there was, what do we do with the leading coefficient when it isn't 1? We're not so worrying about the value because for this one, the one that's up on the screen now, its coefficient was 1. If it was 2, all the curves would just be squeezed tighter to the y-axis. If it's 10, squeezed even tighter to the y-axis. If it was a fraction, stretched away from the y-axis. That's what the number does. It's a dilation, a compressing or a stretching.
Will it be monotone on what we got?
No. That's a year 12 worry. Dilation's a year 12 worry. We just need, what we're looking for in year 11 now is, can you identify the x-intercepts? When you look at the leading coefficient, did you recognize the one that's on the screen now, it was negative. So it starts down the bottom. It comes up and passes through -7. It turned around somewhere because it had to come back down and pass through -3. Once it passed through -3, it had to turn around again because it needed to pass through -1.5. And it took off, and at some point again, it had to pass through the y-axis at 126. And at some point, we know it needed to turn again to pass through 2 to finish down the bottom. Is that okay? It's all about where do I start, where do I end? How many times do I need to pass through my x-axis? Because that will tell me how many times I need to worry about turning. Is that okay? We're not worrying about how close does it look to the actual graph. We're worrying, can you get the arms up, arms down, Travolta curve part right? Did you recognize it needed to turn above an x-axis here, below an x-axis here? It bounced on the x-axis here. That's really what we're looking for at the moment. Is everyone okay with that? Beautiful. For the next little bit, before period 4 starts, just to the right of that, can you sketch these polynomials for me? Have a go at sketching them using that idea of C of P. Shape is the degree, intercepts, your coefficients, part of your shape. Have a go at those. The first 3, I think, were cubics, and then they start getting funky after that. And when I say funky, just different. I've also then got another worksheet there that I'd like you to have a go at, which is a little bit more neater because I found it and typed it. And for your fun, all the way at the bottom there, for your marking pleasure, I have included my answers. So you can double check against myself. The other thing, what could you also do to check if your shape was roughly right? Desmos. You could literally type that into Desmos and GeoGebra and it will graph it and you can look at the shape. Yeah, my shape kind of looked like that. Sweet? Beautiful.